So let's get ready to reveal our image. And remember that one of Webb's jobs is to find out about galaxies, more about the galaxies, but also to help us to understand how they change. And this image is going to be very, very useful for that. Let's reveal it now. There it is. It's called Stephan's Quintet, and it's wondrous. Giovanna, what are we looking at?
Yes, like it's a quintet, so we are looking at 5 galaxies. Galaxies are this giant structure that, as we've seen, we see everywhere around us in the universe. They contain from million to 100 billions of stars, and in fact we live in one of them, the Milky Way. And here we see 5 of them. This is a closer galaxy in the foreground, and these 4 are at a distance of about 300 million light years from us, and are locked in a close interaction, a sort of cosmic dance driven by the gravitational force. You can see here these two in a process of merging within each other. This is a very important image and an area to study, because it really shows the type of interaction that drives the evolution of galaxies. That's the mechanism of galaxies' growth.
I love this image of the cosmic dance moving through each other. Mark, there's a lot going on, though, in this image, isn't there?
There is. So this is a near-infrared image and a mid-infrared infrared image combined. And when we zoom in on the left-hand side here, we see this foreground galaxy. We see lots of individual stars in there, actually resolved as point sources, which is remarkable. And then as we pan across, we actually see the galaxies in the merging galaxies. We now see gas and dust, which is being heated up in the collision between those galaxies. And that's a place where new stars are being born today. So we're actually seeing the process of creation of new stars in this region. And then when we look in the background here, we see not only the galaxies at 300 million light years, but also stars in our own galaxy. These snowflake structures that you see here, those are nearby stars, but in the corner and around the edges we see galaxies which are much, much more distant, much further away. So similar in some sense to the ones that we saw earlier on in that deep field. And so this image actually takes us from the nearby galaxy, our own Milky Way, through these galaxies which are evolving today all the way to the distant universe. And in a way it captures cosmic evolution of galaxies over those 13.8 billion years.
So we have another image, don't we, that we can
exactly
look at?
So if we strip away the near-infrared view there of the stars predominantly, now in the mid-infrared with MIRI alone, we see mostly gas and dust. So we see the same galaxies again, the two merging, and then we also see something very interesting up at the top here, because this top galaxy has something new and bright in the middle of it. And Giovanna, tell us what that is.
Yeah, that's an active black hole. We cannot see the black hole itself, but we see the material swirling around, being swallowed by this sort of cosmic monsters, and this gas gets heated to extremely high temperature as it falls onto the black hole, and it becomes very bright. In fact, this is how shiny is the galaxy. Here we see luminosity that are 40 billion times the luminosity of our suns. It's really, really bright. And with NIRSpec, we can zoom into this area, and we have this technology that allows us to take thousands of images at different wavelength channels, so see this distribution of the gas, what's going on in the gas in different regions of this core area, and understand the composition of the gas, the velocities, the temperature. So that's very important to understand the physics.
So it's giving us so much information, and it just shows the power of this telescope. Mark, this is just the beginning, though, isn't it?
I think that's a very important takeaway from today. You know, these are like pictures just taken over a period of 5 days, and every 5 days we're getting more data which will contribute more in that direction. It's a culmination of decades of work, but it's just the beginning of decades. And you know what we've seen today with these images is essentially that we're ready now. This telescope is working fantastically well, and you know, to borrow a phrase from a famous rock musician, you know, we're ready to turn this telescope up to 11. It really is time. It's fantastic.
Thank you very much indeed, both of you. Back to you, Michelle.